Hello guys, welcome to today's video. I am Karthik K. Kulkarni from Shivanteshwara College of Engineering. My today's topic. Hello guys, today we are going to learn about Introduction to Economic Analysis for Energy and Environment, Current Energy Landscape, Environmental Impacts, Renewable Energy Sources, Economic Benefits of Renewable Energy Sources, Scope of an Investment Project, Characterization of an Investment Project, and Conclusion. Introduction. In recent years, there has been a growing concern for the environment and its impact on economy. Current energy landscapes. The current energy landscape is dominated by non-renewable sources such as coal, oil, and natural gas. These sources are finite and their extraction and use have significant environmental impacts, including air and water pollution, greenhouse gas emissions, and habitat destruction. Despite these drawbacks, non-renewable sources since account for the majority of global energy production and consumption. Environmental impacts: air pollution reduction, water conservation, land use impact. Air pollution reduction. Renewable energy sources such as wind and solar power can significantly reduce air pollution by reducing the need of fossil fuels. Water conservation. Hydroelectric dams can provide clean energy while also conserving water resources by regulating water flow and preventing flooding. Land use impact. Renewable energy sources such as wind and solar power require less land use than traditional energy sources such as coal mines or oil rigs, reducing the impact on natural habitats and wildlife. Renewable energy sources. Solar energy, wind energy, hydroelectric energy are some of the sources of renewable energy. Solar energy. Solar energy is harnessed through the use of photovoltaic cells that convert sunlight into electricity. It is a clean, renewable source of energy that can be used in a variety of applications from powering homes to providing electricity for large-scale industrial operations. Wind energy. Wind energy is generated by using wind turbines that capture kinetic energy of the wind and convert it into electrical energy. It is a clean, renewable energy that can be used to power homes and businesses as well as large-scale industrial operations. Hydroelectric energy. Hydroelectric energy is generated by use of dams that capture the kinetic energy of flowing water and convert it into electricity. It is clean, renewable source of energy that can be used to power homes, businesses, and also large scale of industrial operations. Economic benefits of renewable energy. Job creation. Renewable energy technologies have potential to create more jobs than traditional energy sources. The solar energy, for example, has seen job growth over 150% in past decade. Cost savings. Renewable energy sources can lead to significant cost savings for consumers and businesses. Solar and wind power, for example, have become increasingly competitive with traditional energy sources in terms of cost. Reduce dependencies on fossil fuels. Renewable energy sources can reduce dependencies on fossil fuels, which are subject to price volatility and geopolitical risks. This can lead to greater energy security and stability. Scope. This presentation explores the application of economic analysis within the energy and environmental domains. It dwells into the assessment of costs, benefits, and trade-offs associated with various energy sources, technologies, and environmental policies. The scope encompasses discussions on externalities, discounting, sustainable development, and life cycle assessment, emphasizing the importance of integrating economic, environmental, and social consideration for informed decision making. Scope of an investment project. Wind energy generation. Objectives. The primary objective is to plan, develop, and operate a wind energy generation project with the goal of producing clean, renewable electricity to contribute the regional power grid while minimizing environmental impact. Project description. The project involves site selection, procurement of wind turbines and associated equipment, obtaining necessary permits and regulatory approvals, construction of wind turbine foundations and towers, electrical infrastructure, and connecting the grid. It also includes ongoing operation and maintenance activities. Deliverables. The primary deliverable is the functional wind energy generation facility, which consists of wind turbine foundations, electrical systems, grid connection infrastructure, and monitoring equipment. Comprehensive documentation environmental impact assessments, and safety protocols are also deliverables. Constraints. Constraints may include budget limitations, adherence to environmental regulations such as wildlife protection measures, safety standards, and project timeline constraints. Compliance with local zoning laws and community engagement may also be essential constraints. Defining the project scope for wind energy generation provides clarity on its goals, boundaries, and critical components, ensuring effective project management and alignment with sustainability objectives. Characterization of an investment project. Let us consider an example project of development of a wind farm. Here we have to consider four main key points: technical feasibility, financial feasibility, economic impact, and lastly, environmental considerations. Technical feasibility. Technological requirements. Assess availability of wind turbine technology and transmission infrastructure. Resource availability. Evaluate local skills and manufacturing capabilities. Implementation plan. Outline site location, site selection, grid connection, and maintenance schedules. Financial feasibility. Cost estimation. Calculate capital and operational costs. Revenue projections. Estimate revenue based on energy generation capacity and electricity prices. Funding sources. Identify potential investors, loans, or grants. Financial risks. Assess risks like price fluctuations and regulatory changes. Economic impact. Job creation. Estimate construction and operational job opportunities. Contribution to GDP. Assess the project's economic contribution. Overall economic benefits. Identify increased tax revenue and infrastructure improvements. Environmental consideration. Environmental impact assessment. Evaluate effects on ecosystem by birds migration and noise pollution. Mitigation measures. Develop strategies like bird-friendly turbine designs and regular monitoring. Compliance and regulations. Ensure adherence to environmental laws and permits. This concise characterization helps project developers evaluate feasibility, secure funding, and plan for environmental sustainability while reaping economic benefits. Conclusion. Economic analysis guides decision in energy and environment by assessing costs, benefits, and trade-offs. It addresses externalities, applies discounting, and fosters sustainable development. By integrating economics, environment, and society, we can shape a harmonious future for energy and the environment.